Hello class, good day once again, and this is our second part of our lesson for this week, and we are still on our fourth chapter, which is the equilibrium of rigid bodies. And previously we have dealt about rigid bodies like beams and other structural members that are in equilibrium, and we have utilized our common equilibrium equations, which were the summation of forces and the summation of moments. And we also have learned some support reactions that are important, especially for those rigid body structural members. And now, for our second part of this class, we will be dealing about 2 and 3 force members. And the goal for this lesson is that we should be able to identify what are 2 force members and what are 3 force members. And how can those concepts, how can those kind of members be able to help us solve for rigid body problems. Okay? Some equilibrium problems can be simplified if you know some of these important concepts. Because if a body is subjected to either 2 or 3 forces, then there are techniques for you to be able to simplify or on how to solve these kinds of problems. And let us first deal with the 2 force member. So when you say a member is a 2 force member, then obviously, for example, this is your member. Okay? That is your member, and this member is subjected to forces FA and FB. So this member daw is said to be a 2 force member. Why? Because obviously, as you can see in this case, this member is subjected to only 2 forces, your FA and FB. And if we say that this member is in equilibrium, okay? So the sum of FA and FB should be 0, right? If mo yung tag-equilibrium ani. So therefore, unsa may imong makonclude sa aning duha na to ka forces if 2 force member ning atong member dere. So again, if this member is in equilibrium, then we can say that the sum of these 2 forces must be equal to what? Must be equal to 0. So therefore, what can we conclude in this case? Since duha ra man siya ka forces, therefore, para equilibrium siya, dapat equal ni sila og magnitude, and then they are acting at the opposite directions. Okay? Take note about that. So if a member is a 2 force member, so this one is subjected to 2 force. So if your member is in equilibrium, then therefore the forces that is exerting on your member must be equal magnitude but acting on the opposite direction. So therefore, dili day niing ani ang atong mga forces, pero dapat ing-ani na sila. Okay? And your FB is equal to negative FA. So therefore, if you are going to sum the forces of this one, this should be equal to 0. And take note, unsay direction ani nga force? Ang direction ani nga force dapat collinear siya sa aning duha ka points. So di ba naatay points diri A and B. Okay? And the direction of these forces must be collinear to the connecting line of your A and B points. So, mo na ang direction sa atong force. So, they are equal in magnitude, opposite in direction, and it should be directed along the points of application sa duha nimo ka points. Understood. So, that is your two-force member. And when you're dealing with problems that maka-notice mo nga, hala ka ni kay two-force member ni. So, i-identify lang nimo ang iyang points A and B, and then, makibaw na ka unsay direction sa atong forces ana. And your forces again should be equal magnitude but opposite in direction. Okay? So, how about for the moment of this one? So, if you are going to sum the moments everywhere at whatever points in this member, it will always be equal to 0. Why? Because, for example, mag-moment ka diri, then, mo na yung moment arm, and equal man na sila magnitude, so, mo 0 na siya. Kung diri ka mag-moment, mo 0 gyapon na siya. Kung bisag asa ka mag-moment, 0 gyapon na ang moment aning atong member. Okay? So, there is no moment, there is no resultant force. So, equilibrium ni ang atong member. Okay? Mato. Another. How about a three-force member? So, for example, we have this beam. If a member is a two-force member, then that member is subjected to two forces. And if a member is a three-force member, then obviously, that member should be subjected to three forces. So, for a three-force member, let's say, we have this beam. And your beam is subjected to three forces, and those forces are applied in these 3 points. Okay? So we have a force F1 here. We have a force F2 here. And there is atong F3, wala pa kung tahit ka nakibaw. Okay. So, if we say that this member is in equilibrium, then your F1, your F2, and your F3 should be equal to 0. So, the forces F1, F2, and F3 should be equal to 0. And also, your moment should be equal to 0. So, when can you say that all these 3 forces, this one, and this one, will equate into 0 ang ilang moment? Again, kung mag-moment sila and then na-point ani nila nga mag-concurrent ni sila. So, when will that be? So, ato isulting. Ngani. Ato mangita ta kung asa ni mag-intersect ang atong F1 ug F2. So, para pangita ni mag-intersection, ngana lang ka. Okay? And then, vertical sa F2. And then, you will find this point. And let's call this one as point O. Okay? Now, you can identify the direction of your F3 to make this forces equilibrium. Ang direction sa atong F3 is actually from this point to this point. So, maghimo lang na i-connect ang duha ka points. And this is the direction of your F3. And your F3 should be going at this direction down. Okay? So, with this setup, your F1, your F2, and your F3, if we are going to sum the forces and to sum the moments of this system, then we will arrive at an answer of 0. So therefore, this member is in equilibrium in this case. So usasad na sa technique in solving this kind of problem. So if you have 3 forces and you have identified 2 of those forces and you still have to determine your third force, then you can use this concept, your 3-force member, in order for you to solve the third force. Another instance, and this is a special case. Yes, this is a special case. So you have this beam, and instead of having forces that are angled or inclined, then this is another special case for your 3-force members nga ang imong tulo ka forces are parallel with each other. So this is your F1, this is your F2, and this is your F3. Kani daw, if you are going to sum the forces and to sum the moments, equilibrium gyapon ang iyang result. Okay? Okay? So, take note of this one because probably you might be able to use this one on the later problems that we will be having. Pero still, you can use the summation of forces, summation of moments, ani. Pero, basin, this is much more convenient for you to use than using the other method. Okay! So let's have here an example. We have this lever ABC that is pin supported at A, at point A. So pin supported siya at point A, and connect siya og kaning link nato nga kaning atong gitawag nga BD. Okay? And there is a 400 newtons that is applied at the handle of this lever. So we have to determine now the forces on your pin A. Okay? So ato i-draw. Okay, basta lang. Kailangan mag... Okay. So we had this problem, and there is a 400 newtons of force that is applied on this handle of this lever, and we have to determine the forces in this portion here, your AY and your AX. So how can we solve this problem? This is a link, and if you are going to pull this one, so may tabuan eh, mabira ni siya, diba? And what is the direction of the biraan ni nga atong link? We learned that this link is what? This is a member, this is a separate member, and this is subjected to two forces, 1 and 2. So we can say that this link BD is a 2-force member. And if we're going to draw that one, this is 0.2 meters, and this is 0.2 meters. And we knew that this one should be acting along this line. The direction of the force should be acting along that line, as stated on our 2-force member previously. Okay? And our force, since nainat man ni siya, ay nabira, therefore, ang atong force, gibira na ang atong member. Okay? And let's call this one as F. So, But we knew that this one has an angle of 45 degrees. So, una na siya. And if we're going to remove this link here and to isolate your lever na lang, what will happen? Ano yung mahitabo niya? So, the force is applied at here, at this point, and then direction should be going away from it. And this is your 45 degrees. Okay. Ngano pa yung aning direction man nga ang sa diri nga point kay padung man didto. Kay di ba gibira man ni siya ang atong lever, ang kaning atong link. And then kani pagbira nato sa 400 newtons dapat nabira pod ni ang atong point dere. So dapat it should be going away from this member pod as well. Kaya kung padong siya dito, nag-push na noon ka ani. Okay? Pero this point here is subjected to tension. Mura gibira siya diri pagbira aning 400 newtons. Then the force should be going away from the member. Okay? Sige. So, now we have learned that this one is a two-force member, and we learned that the direction of the force should be 45 degrees because this is a two-force member sa itong link. And we can also say that this one is a three-force member. 1, 2, and 3. So this lever here is a three-force member, and we can use whatever equation that we would like to solve for this one. So ato ni remove ang kaning pin, but we knew that your pin supports loads that are along the x and y components. Pero pwede lang po na nato butangan ng angle, and then we will determine their x and y later on. But now, what is the direction sa katong atong kuan, atong unknown nga force? Diba? We can say nga ing-ani na lang kuntahe ang atong AY and AX. Okay. This is F. On our previous knowledge on solving this kind of problem, what are we going to do? Diba? We can solve for F in this case. Saan man? By using summation of moments at point A. Diba? Ma-solve na natong F ana. So, saan man nato? Sige, ang ako gibuhat karon, ako pa to gi-solve gamit sa atong nahibaw-an nga solution. Okay? But later on, we will solve this one by using our knowledge in three-force member. Sige. So, unsa man ni? Diba? This is Fx and Fy. Okay. So, unsa man na? Ato unahon ang Fx. So, F sine of 45 and moment arm of, ilan man na siya? 0.2 plus F cosine of 45 times 0.1 minus 400 times 0.7 equals to 0. And with this equation, we can solve for F. Ako nagidiretso ng mga moment ha. So, F sine 45 mo ni siya. And then, 0.2 ang distance ani. Fy, so F cosine 45. And 0.1 ang distance ani. And your 400, and kani nga distance is 0.5 plus 0.2, so that is 0.7. Okay? So you can solve for your F as you will have an answer of 1,319.93 newtons, or that is 1.32 kilonewtons. newtons. Okay? So that is the answer of your F. So we already have solved for our F. Then, we can use summation of forces along the X going there para atong AX, which is equal to AX minus 1.32 kilonewtons. 1.32 kilonewtons sine of 45. Then, minus ba? Plus di ay. Plus di ay ni. And then minus 400 kilonewtons equals to 0. 1, 2, 3. Okay, so your AX here is equal to X plus an sine 45 minus 400. So your answer here is negative 533.33, and or this is 533.33 going to the right. Okay? And for your AY, summation of forces along the Y going up is equal to AY minus Fy, which is 1.32 cosine of 45. Wala naman tayo lain, equals to 0. So your AY di is equal to take note ha, this is newtons. So that is 933.33 newtons going up. So to get your force at A, imong baton, imo ra na Pythagorean theorem, di ba? So 533.33 squared plus 933 squared. So what is the answer of that one? So the answer is 1.07 kilonewtons. Okay. Take note, we have these two answers, 1.32 and 1.07 kilonewtons. So your FDI, your F is 1.32 and your FA is 1.07 kilonewtons. So take note of this answer. So ato to gigamit ang atong normal nga pag-solve sa aning nga member. But how about if we are going to solve this one using our knowledge in 3/4 member? I don't know, maybe this would be much easier for you compared sa katong atong taas nga solution gamay. Pero I'll just give you another option. So, di ba, we have learned that para equilibrium ang imong member that is subjected to 3/4, ang imong una buhaton, imo pangitaon kung asa na sila mag-intersect ang aning atong duha ka known nga force. Then let's just say that these two forces will intersect at this point. This is your point O. And since your third force is applied in this point right here, then you can say that the direction of your third force should be going at this direction as well. Dapat mo concurrent sila ani nga point. Okay? So therefore, this is your FA. Okay? Wala ta aning fx ug fy kay atong gi-focus karon kay ang 3/4 member. So, na-apply na to ang concept sa 3/4 member. Your 400, your F and your FA is exerting on the same point at point O. Now, how can we solve this one? So we knew that this angle right here is 45 degrees. But we don't know what angle this one is. Okay. So, unsaon man na siya? We should first identify the angle. Unsaon man nato pagkuhaan ni nga angle? We can use our trigo. Because given diri nga 0.4 meters ni siya and then kani is 0.7 meters. This is according to our drawing hanga dito sa example. So, for you to be able to get your theta, opposite over adjacent. So, that is tangent of theta is equal to 0.7 meters over 0.4 meters. So, that is inverse tan. Ay, ako lang ito, gidiretso di ay 0.7 over 0.4. So, that is that is 60.26 degrees. So, this one there is 60.26. Okay? And, kung ato to gibutang ang angle kaganiha ang atong force sa FA, di ba? Nakibaw man ta nga ang kadong FAX adto niya is 533.33 and ang atong FY adto niya is 933.33. Sige daw, ato daw na i-tangent be. So, theta is equal to inverse tan of 933 over 533. Be? Inverse tan of 933.33 divided by 533.33. So, the answer here is 60.26 degrees. So, 60.26 degrees. So, same sila. Diba? Lahi lang pagi ato gigamit. Okay. So, karon padayon ta. So, we know that this one is 60.26 degrees. And we can again solve this one by using our summation of forces along the x and y. And we are not going to use moments. Diba? Weird. Pero this is just another kind of solution that you might probably use. So this is summation of forces along the x sa tauna. And let's say we're going there. Equals to, ini FA. So this one is 60. So FAX is FA cosine of 60.26 degrees minus F cosine of 45 degrees plus 400 equals to 0. This is your first equation. Equation number 1. You can't answer this one directly because you have two unknowns. So you still have another equation, that summation of forces along the y. Let's say this is going up. So FA sine of 60.26 degrees then minus F sine of 45 degrees, and we don't have 400 because that is horizontal, which is equal to 0. And this is your equation number 2. Now, if you're going to solve two equations for two unknowns, then by using your algebra, you will finally arrive at the answer for your FA as 1.07 kilonewtons. Kamo na lang yung pag-calculate na ha, pero I'm sure that they will still arrive at the same answer, and your F is equal to 1.32 kilonewtons. And this is your answer. So that is how you solve this kind of problem by using your knowledge in 3/4 and 2/4 member. So you can either solve this one by using this solution or the other solution that I have shown to you before. So it is your prerogative and I won't buot you. Okay? So, mo lang to ang atong lesson for this week. And that is your 2/4 and 3/4 member. And as a summary for this lesson, you have learned your 2/4 member and your 3/4 member. What are those and say gamitan na nila. And you have knew some techniques on how to solve problems, how to solve the unknown forces of a member by using your knowledge in 2/4 and 3/4 member. So, have you understood our lesson for this week? And if you haven't yet, then it is good for you to watch this video again or to make some practices for you to be able to solve this kind of problem much better. Okay? So, if you don't have any questions, then enjoy your week. So, see you again on our next lesson. Bye!